Hello students, today we are going to solve questions from atomic structure from the CET question paper which was held on 19/6/2023. Now let us take up questions from atomic structure. The first question here we have is, if the shortest wavelength of hydrogen atom in Lyman series is X, the longest wavelength in Balmer series of helium plus is. Okay. Now let us do it. First of all, let us have the relationship between the wavelength and then energy. Okay. And after which we will be trying to solve this question. See, basically, whenever we are talking about Lyman series and Balmer series, we all of us know that this is related to line spectra of hydrogen atom, right? So if we are talking about line spectra of hydrogen atom, so we have the expression where mu bar is equal to, that is RH, Rydberg constant, Z square, which is nothing but N1 square minus 1 by N2 square. So this is the general formula by which we will be expressing line spectrum of hydrogen. Okay. Now, basically in this case, we are expressing this in terms of wave number, right? We also know the relationship between wave number as well as the lambda, which is nothing but wavelength. So what is wave number? Wave number is basically 1 by lambda. So wave number is inversely proportional to lambda, correct? No? So which means that when we are talking about the shortest wavelength of hydrogen atom in Lyman series, then what would be N1 and N2? So in case of Lyman series, N1 will be always equal to the first level, isn't it? The ground state. Now, in order to get the shortest wavelength, definitely N2 must be equal to infinity. N2 must be equal to infinity. Why N2 is equal to infinity? Because from N1, that is from N2 to, if N1 is coming, that is emission is happening, then it will have energy, let us assume it is E. Okay. Now we know the relationship between energy and wavelength and frequency. Basically, we write E is equal to H nu, which is also equal to Hc by lambda. If energy is more, wavelength will be less. Now compare the transition which is taking place from, that is emission taking place from N2 to N1 and N infinity to N1. So which will have higher energy? So basically N infinity to N1. So this emission will be corresponding to high energy, and hence the wavelength will be shortest. Wavelength should be shortest. So keeping this in mind, we are now going to get the value of 1 by lambda in terms of RH by substituting N1 to be 1 and N2 to be infinity. Now let us find out what value you would get by substituting these values. Okay. Now 1 by lambda is equal to RH. Z square, atomic number of hydrogen atom is only 1. So let us write 1 square. Okay. Now 1 by, once again, 1 square minus 1 by, which is nothing but infinity square. So this entire term will now become equal to 0, and hence 1 by lambda is equal to RH, right? But in the question, they have given the shortest wavelength to be X. Since here we are writing 1 by lambda is equal to RH, 1 by lambda can be written as 1 by X. So which is equal to here, which is equal to 1 by X. Okay. Now similarly to the second part of the question, the longest wavelength in the Balmer series they are asking. Of course, the formula remains same, the same formula. Rydberg had generalized the formula for line spectrum of hydrogen, where 1 by lambda is equal to RH. Now Z square will once again become the same 1 square value. Now 1 by n square. Here they are saying longest. Longest means Balmer series. The ground state is 2. So it will become 2 square minus 1 by 3 square. Okay. Now on simplification, what do you get? So RH, this is 1 square only. Then this will become 9 minus 4 divided by 36. How much? This is 36. 36. Okay. Now basically this value will become equal to how much? 5 by 36 is equal to 1 by lambda. So 1 by lambda is equal to how much? Sorry students, this is helium. So helium atomic number is 2 square. So it will become 2 square. Andre, here you will be basically getting 4. Howda? So which means that this is 4. So 4 ones are 4 nines are. So which is equal to, that is 1 by lambda is equal to 5 by 9. Okay. Now lambda is assumed to be what? Lambda is assumed to be x, and hence this value will become equal to what? 5 by 9x is equal to 1 by lambda. Now what they are asking? So they are asking in terms of lambda. So lambda value will be equal to 9x by 5. Okay. So which option is correct, students? So here we have option D to be correct. So this option is correct. Now coming to the third question. So what they are asking in the third question, the incorrect statement about Bohr's orbit of hydrogen atom. Okay. Now let us find out which is incorrect statement. So just look into the first formula. What they are saying, radius is equal to n square h square by 4 pi square m e square by 4 pi epsilon naught. So this is absolutely correct formula. And E is also once again absolutely, that is energy. Formula is also absolutely correct. That is 1 by n square 2 pi square m e square by 4 pi epsilon naught, that is whole square by h square. This is also absolutely correct. Now coming to option B, what is option B? Kinetic energy of electron is equal to potential energy of electron. Is it correct? No. So now let us find out why this is incorrect. Okay. Now why this is incorrect? So basically we all of us know that according to Bohr's concept, the energy of the electron will be equal to the summation of potential energy as well as kinetic energy, right? So now let us do the relationship between potential energy as well as kinetic energy, and let us find out why kinetic energy of electron is not equal to potential energy of the electron. Okay. Now we know that kinetic energy, that is total energy, E is equal to kinetic energy plus potential energy. Okay. So basically we know the formulas, that is Ke, that is kinetic energy, which is equal to 2 pi square. Okay. 2 pi square K square me 4 divided by n square h square is the formula, and we have potential energy. So potential energy will be always expressed as the negative magnitude with the negative magnitude, which means that it is 4 pi square K square me 4 divided by n square h square. So from these two expressions, it is quite evident that potential energy of electron is not equal to kinetic energy. And in simpler terms, if you want to understand how potential energy and kinetic energy are related, you can also write it as kinetic energy is equal to minus 1 by 2 into potential energy, or our potential energy will be equal to minus 2 into kinetic energy. So these are the two relationships in which the electrons are related, and hence option B is the incorrect statement for this question, that is third question. Hope you are understanding, students. Now let us take up the next question. Which of the following has the maximum number of unpaired electrons? Okay, undoubtedly it is option C, that is Fe2 plus. Now let us try to solve it and understand why iron 2 plus is having basically how many unpaired electrons or more number of unpaired electrons. Now first of all, take up the first option. So what is the first option, students? They are giving Mg2 plus. We know atomic number of Mg. So Mg's atomic number is 12. Okay. When it is becoming Mg2 plus, it will have 10 electrons. So it will be accommodated as 1s2, 2s2, 2p6, 10 electrons, which means that it is having completely filled orbitals, and hence no unpaired electrons. Okay, now coming to the second case. So what is the second case? Titanium 3 plus, which is a transition matter. So that is titanium 3 plus. Okay, so what is the atomic number of titanium? Basically, atomic number of titanium, that is titanium, will have 22 as total number of electrons. So if it is 22, we will accommodate the electrons like this. That is the electronic configuration argon, and it is 3d2 4s2. Okay, if you remove 3 electrons, basically you would be removing these 2 electrons and 1 electron from 3d. So which means that in case of titanium 3 plus, you will have argon and then 3d1 as electronic configuration, which means that it has one unpaired electron. Okay. Now coming to vanadium 3 plus. So vanadium 3 plus, basically vanadium will be having how many, like what is its atomic number? So vanadium has 23. So vanadium has 23. When it is becoming, let us first, do the electronic configuration. Argon, so 3d3, 4s2. When it is becoming V3 plus, what does it mean then? So there is removal of 3 electrons. Which 3 electrons? These 2 electrons. And from here, 1 electron, which means that it will have 3d, 23, right? 3d2. So 2 unpaired electrons will be there. 2 unpaired electrons will be there. Now coming to Fe2 plus. Basically, Fe's atomic number is 26. How do you configure it? Ar, it is 3d6, 4s2. And in Fe2 plus state, it will be losing 2 electrons. So hence it will have argon, that is inert gas configuration, it accounts for 18 electrons, then it will become 3d6. So which means that these 2 electrons will be removed. So when it is becoming 3d6, basically, how do you show the electronic configuration in the 3d orbitals? We all of us know that 3d has 5 orbitals. 3d has 5 orbitals, except in the first orbital, remaining all of them will be having 1 electron each, and hence how many number of unpaired electrons? 4 unpaired electrons are there. Hence option C is the correct option for question number 4. So hope you are understanding. So now let us take up the next question. Okay. So what is the next question, students? The fifth question. So what they are saying, choose the correct statement among the following. Okay, now let us take up the first option. Psi square represents the atomic orbital. Yes, of course, psi square is nothing but the maximum probability of finding an electron around the three-dimensional, that is in the three-dimensional space around the nucleus. So hence psi square represents atomic orbital. Hence this is true, correct statement. Now coming to the second one. So what the second one they are saying? the number of peaks in radial distribution is equal to n minus L. Okay, now this can be understood in this way, where we know the formula for determining number of radial nodes, right? So what is the formula for determining number of radial nodes? So radial nodes, we have a formula which is equal to n minus L minus 1. Okay, and we also know that to find out something called number of peaks. Okay, number of peaks. So what is number of peaks? Number of peaks so number of peaks, we if in order to find out, we know the relationship between radial nodes is equal to we say the formula that is peaks minus 1. Okay, now equating radial nodes is equal to peaks and minus 1, you will get n minus L minus 1, which is equal to peaks, number of peaks minus 1. So now if you want to know how many number of peaks that are possible, peaks will be equal to what? So this minus 1 and minus 1 gets cancelled. So you will get only n minus L. So hence the total number of peaks from the radial distribution curve will be always equal to n minus 1, which will corresponds to the total number of the peaks in the radial distribution. So hence option B is also correct. Now coming to option C. A node is a point in space around nucleus where the wave function psi has 0 value. Yes, of course, node is nothing but the point where the probability of finding an electron is absolutely 0, and hence psi value will also become 0, because we all of us know psi doesn't have any physical value, but just it's a mathematical function, isn't it? So hence this also will become 0. So option C is also correct, and hence which option is correct for fifth question? So option D would be correct, which is nothing but all of the above. All are correct statements only. Now coming to the sixth question. So what is the question? The wave number of spectral line in emission spectrum of hydrogen will be equal to 8 by 9 times the Rydberg constant if the electron jumps from. Okay, so this is once again related to the line spectrum of hydrogen. So we have learnt a formula. Okay, Rydberg formula for what? In terms of wave number for the line spectrum of hydrogen-like species. So where RH is the Rydberg constant, Z square is the atomic number, and we know the formula, that is 1 by N1 square minus 1 by N2 square, right? Now this question answer can be directly solved from the options only. Now what they are saying? So they are saying that the wave number, that is nu bar, okay, that is nu bar is equal to 8 by 9 times of Rydberg constant, it seems. When do you get this 8 by 9? So assuming n is equal to 3, and which means that from third energy level to n first energy level, if the transition is happening, then there will be possibility of formation of 8 by 9 RH. That is what they are asking. Let us try. Now, n1, if you assume this to be 1 square minus 1 by 3 square, what will you get? See, basically, I'm just substituting the values, since this is for hydrogen atom itself they are asking. So need not to take the Z, because Z value will become 1. So 1 square, and this will become 1 by 1 square minus 1 by 3 square. So on simplification, what do you get? So RH 1 square. Here you will get 9 minus 1 by 9. Okay, which is equal to 8 by 9 of RH. So hence option A is correct for the sixth question. So it can't be 10 and n is equal to 1. If it is this, then what will happen? Basically 100 minus 1, 99 by 100 you would get in this case. So that is also wrong. Here 80 divided by 81 you will get. That is also wrong. And here basically you will get how much? 3 by 4 RH. So this is also wrong. Now coming to the seventh question. What is the seventh question, students? The energy of hydrogen atom in its ground state is minus 13.6 electron volt. The energy of the level corresponding to the quantum number n is equal to 5. So once again, this is a direct question. Direct question in the sense we know the Bohr's energy, correct? So what is Bohr's energy? So Bohr's energy is equal to, let us write the value, that is En is equal to minus 13.6 z square by n square. Okay, now what they are giving? They are giving the principal quantum number. They are asking it for hydrogen atom. So hydrogen atom means once again z will become 1 only. So this will be equal to what? So which is equal to minus 13.6 into 1 square divided by n square is 5. N is equal to 5. So n square will become 25. So if you simplify this, you will get the option of minus 0.544 electron volt. So which is correct? So among this is 0.54. So option B is correct. Okay. Now coming to the eighth question, and before which let us now okay. Which question are we at? Eighth question. So this is done. Option B is correct. According to Bohr's theory, the angular momentum of an electron in fifth orbit. Okay, they are asking in fifth orbit. So we know the formula of angular momentum. So this is also once again based on Bohr's atomic model. So Bohr had given something called ME, that is mass of electron, velocity. This is small r, students. So small r, MEVR. Okay, let me erase and write. MEVR is equal to NH by 2 pi. So according to Bohr's concept, he actually states that the electron can occupy or revolve in the orbit whose angular momentum will be, integral multiples of h by 2 pi. So which means that MEVR will be having NH by 2 pi. Now what is the n value they are giving in the question? So they are giving n value to be 5. So which means that the angular momentum will be equal to 5 into h by 2 pi. So 2 ones and 2.5. So the answer will become 2.5 into h by 2 pi. So which is the correct answer? So option D is correct. Now coming to the ninth question. The radius of second Bohr's orbit of hydrogen atom is, okay. So once again, we know the radius formula according to Bohr's concept. So we know that Rn is equal to 0.529 into what is the formula? Second orbital. So basically it is n square by z. So this is the formula. Now what they have given, this is in terms of angstrom units. Now first of all let us calculate. When you are calculating, it becomes 0.529 into n square is 2 square. So 2 square by z is equal to 1. So on simplification, basically you would be getting a value of 0.0. sorry, 1 second. In angstrom units, when you are multiplying this, that is 0.529 into 4, you get a value of 2 point, you get a value of 2.116. Okay, angstrom units you will get, but this need to be expressed in terms of nanometers, and you know the relationship between nanometers and angstrom meters, that is 1 nanometer is equal to 10 angstrom units. And if you want to convert this 116 angstrom units to nanometers, what you have to do? So this value, that is 2.116 divided by 10, if you do, you get the answer, which is nothing but option C. So option C would be correct. That is 0.2116 nanometers. Okay. Now let us take up the next question. So what is the next question, students? So the next question is asking the electronic transitions from n is equal to 2 to n is equal to 1 will produce shortest wavelength. Okay, where n is the principal quantum state. Okay, so they are giving different ions, that is different species which are related to us hydrogen atom, except H plus, because H plus doesn't have any electrons itself. Correct. Now lithium 2 plus, He plus, and hydrogen. So all these three species will have 1 electron each, isn't it? Now what they are asking, they are asking we to determine shortest wavelength. Which one will produce the shortest wavelength when the transition is happening between N2 to N1. So this is once again based on the same concept. What is the same concept? That is line spectra in terms of 1 by lambda. So which is equal to Rydberg constant and Z square, then 1 by N1 square minus 1 by N2 square. Now to get the shortest wavelength, basically the atomic number should be high, because atomic number is inversely proportional to lambda. So among the options given, the atomic number is high for lithium. So lithium's atomic number is 3, and hence we will be able to observe the shortest wavelength only in case of lithium. So based on which relationship, students, that is Z, atomic number is inversely proportional to lambda. As atomic number is increasing, the wavelength will also be decreasing, and that will become shortest. So among all these three options, hydrogen has atomic number of 1, helium has atomic number of 2, lithium has atomic number of 3. So higher is the atomic number, wavelength will be the shortest. Okay, so option A is correct. Now coming to the 11th question, Stark effect refers to the, so once again, this is very, very simple. Splitting up of the lines in an emission spectrum in the presence of an external electrostatic field. So option A only is correct. Why A is correct? Because there are two effects which we have learned. One is called Stark effect, the other one is called Zeeman effect. So Stark effect happens in the external electric field or electrostatic field, and Zeeman effect takes place in the presence of magnetic field. So which means that random scattering of light wave colloidal particles, all these things are just, doesn't relate to the Stark effect, and option A only is correct. Now coming to question number 12. So what is question number 12? Which of the following sets of quantum number is correct for an electron in 4f orbital? So based on writing 4f, it is understood that n must be equal to 4, the principal quantum number, and L value ranges from 0 to n minus 1. So 0 to n minus 1 means it can be 0, it can be 1, it can be 2, and it can be 3. Correct? And what is the ML values? So ML values usually ranges from plus L to, that is, minus L. And how many L values are possible if n is equal to 4? So it is based on, what is it? 2L plus 1. Okay, so 2L plus 1. So for F, L value is equal to 3. L value is equal to 3, because we all of us know, based on the azimuthal quantum number, if L is equal to 0, then it is S. If L is equal to 1, it is P. If L is equal to 2, it is D. And L is equal to 3, it is F. So for to get the total ML values, what we need to do basically, so we have to substitute the L value in 2L plus 1, which is equal to 2 into 3, that is 6 plus 1, you will get 7. So 7 means these value ranges from what? Plus L to minus L. So L is 3. So which means that it can be plus 3, plus 2, plus 1, 0, -1, -2, and -3. So among any of these given values for ML is correct. Now spin can be either plus or minus half. Any value is correct. Now just have a look at the options. So the first option, how come it can be plus 4? So this option is incorrect because n is equal to 4 and L is equal to 3 is possible, but M, that is ML value, magnetic quantum number, ranges from plus 3 to minus 3 and they are giving it as plus 4. So hence this option is very, very wrong. Now coming to option B. So if n is equal to 4, L can never become 4 because L ranges from 0 to n minus 1. 0 to n minus 1. So option B is also incorrect. Now coming to the option C. Option C, where n is equal to 4 correct, L is equal to 3 correct, and M can be plus 1, yes, because it ranges from plus 3 to minus 3. So hence M is equal to plus 1 is correct, and spin is plus half is also absolutely correct, and option C is correct. Now just have a look at the fourth option. So N cannot be 3 if it is 4f orbital. So option D is also incorrect. So which option is correct, students, for 12th question? Option C. Now coming to the 13th question. What is 13? So which of the following statement is relation to the hydrogen atom is correct? Okay. Now what are the options? 3s, 3p and 3d orbitals all have the same energy. Yes, this option is correct and related to hydrogen atom. Okay. Now coming to the second option. 3s, 3p orbitals is lower than 3d orbitals. So this will become correct only in case of multi-electron systems. Okay, so 3s and 3p orbitals, energy will be less only in case of multi-electron system. In case of one electron system, the orbitals having different azimuthal quantum numbers belonging to the same principal quantum number will all have same energy in cases of species having only one electron, especially that is for hydrogen atom. Whereas option B is incorrect for hydrogen atom. 3p is lower than 3d. This is once again incorrect. And 3s orbital is lower in energy than 3p. So all the three options are incorrect except the first one. So this is the correct one. Now coming to the next question. What does the electronic configuration of 1s2, 2s2, 2p5, 3s1 indicate? So as soon as you get these type of questions, just have a count of total number of electrons. So how many are the total number of electrons? Here 2 is there, and here also 2. So put together 4. 4 plus 5 is 9. 9 plus 1 is 10. So there are total 10 electrons present. Now let us look into the options. Ground state of fluorine. So fluorine will have basically, what is the atomic number of fluorine? So fluorine can have atomic number 9 only. In such case, how ground state of fluorine can have 10 electrons? So option A is wrong. Now coming to the second one, excited state of fluorine. Even though it is ground state or excited state, the total number of electrons need to remain same in case of all the elements, isn't it? It can't be more. So hence option B is also wrong. So option B is wrong. Option A is wrong. A is also wrong. Now, what are remaining? Excited state of neon and excited state of O2 minus ion. First, let us take up this third option. Of course, neon will have atomic number of how much, students? So, neon will have atomic number of 10. So, which means that it will have 10 protons in order to neutralize the atom with the charge. So 10 electrons will also be present. So total 10 electrons are present. So basically when you configure this in the ground state, it will become 1s2, 2s2, 2p6 and then, 2p6. That's it, right? 10 electrons, yes. It won't have 3. Correct, no? So now it is understood that this is the ground state electronic configuration, but excitation, what will happen? One of the electron in 2p 6, okay, one electron among the 6 electrons of 2p will be excited to the next, you know, energy level, which is nothing but 3s. So hence option C only would be correct. Okay. Now excited state of oxygen, that is O2 minus ion. See, basically O2 has so many electrons because one oxygen itself we have 8 electrons. So O2 means it is 8 plus 8, 8 plus 8, which is equal to 16 electrons. And then one negative charge means plus 1 electron, which is equal to 70. So this is completely wrong, and which cannot be related to the total number of electrons which is given in the question. That is 1s2, 2s2, 2p5 and 3s1, which is equal to 10 electrons. So for the 14th question, option C only is correct. Now coming to the 15th question. So what is 15th question, students? So the velocity of an electron placed in third orbit of hydrogen atom will be. So once again, we have a formula here. So we have a formula where velocity, okay, velocity is equal to 2.18 into 10 power 8, okay, z by n, z by n. So z is atomic number, n is the orbit, okay, principal quantum number. So what they are giving, third orbit of hydrogen atom, so z will become only 1 and n is equal to 3. So which means that 2.18 divided by, that is into 10 power 8 divided by 3, if you do, you get an option of 0. That is value of 0 0.7266 into 10 power 8, okay, centimeter per second value you will get, centimeter per second. But in the options they have given in terms of 7, okay, 10 power, where is it, 10 power 7. So which means that it becomes, the value will become what? The value will become 7.266 into 10 power 7, okay, centimeter per second. So which option is correct? So option C is correct. Now coming to 16th question. What is the 16th question? The maximum kinetic energy of photoelectrons is directly proportional to the dash of the incident radiation. So this is direct question where, we all of us know it is directly proportional to the frequency. So it is, the frequency is the correct option because kinetic energy E is equal to, so how do we write? E is equal to, so E is equal to H nu Allah. So nu is directly proportional. So hence only the frequency would be directly proportional, not wavelength. So wavelength will be inversely proportional. Okay. So which means that we have almost covered questions from structure of atom. If any question is there, we will also just have a check. Yes, students. So with this, we are done with solving questions from atomic structures. If you have any questions related to atomic structure, you can contact me or approach me during our class hours for further clarifications. Thank you.